Hi guys, Mrs. Everhart here. I'm going to go over the solutions to the practice quiz, and I'll just walk through how I would do these. So, in order to sketch the angle and determine the quadrant, we know that this angle over here is pi. So, whatever denominator the angle's in, I'll make pi in that denominator. So, 7 pi over 7. And then I know half of it's about 3.5 pi over 7, which that's bad, like notation to answer a question. I wouldn't want a decimal and a fraction, but it's my roadmap. So I'm just using it to help me figure out that 4 pi over 7 would be a little past 3.5 pi over 7. So that's going to be quadrant 2. Okay, negative 2 pi over 3, I'm going to do the same thing, but I'm going to build a negative roadmap, which means I'm going to go clockwise, and instead of negative pi, this is going to be negative 3 pi over 3, which means this would be about negative 1.5 pi over 3, which again, if I'm answering a question, I don't want a decimal and a fraction, but for my roadmap, that's fine to help figure out what quadrant that would be in, which is quadrant 3. 275 degrees, that's in degrees, it's a little bit easier for us. We know when we do our quadrant angles, we go around in 90s, so 0, 90, 180, 270. So we can figure out that 275 is going to be in quadrant 4. Okay, the next part asks for positive and negative coterminals, and this is where we gets a little more difficult. I'm going to do my roadmap again in 12s, and I'm going to do it negative, so I'm going clockwise. So this is negative 12 pi over 12, so this would be negative 6 pi over 12. All the way around would be 24 pi over 12. So if I'm sketching negative 5 pi over 12, I'm going to be in quadrant 4. Now one of the coterminals I can do right on that same grid without it being too crazy messy. And if 24 pi over 12 is all the way around, and I've used up 5 pi over 12, 24 minus 5 is going to leave me with 19 pi over 12, and it is in the positive direction. To get another coterminal angle but negative, I'm going to go all the way around. Oops, it's not curving. All the way around. That it would be negative 24 pi over 12, and then I'm going to go negative 5 pi over 12 more. So negative 24 plus negative 5 is going to be negative 29, and then that's pi over 12. Okay, for the next one, we're looking at 7 pi over 9. I'm really going to do these very similar. I'm going to make pi, and in the positive direction, 9 pi over 9. So I know all the way around will be 18 pi over 9. Halfway would be about 4.5 pi over 9. So 7 pi over 9 is going to be in quadrant 2. So I need this negative angle. So if 18 pi over 9 is all the way around, and I've used up 7 pi over 9, I will have 11 pi over 9, but that's going to be in the negative direction. To get a positive angle, I'm going to go all the way around 18 plus 7 more. So 18 and 7 will give me 25, so it's 25 pi over 9. Okay, 240 degrees. That one, when we're in degrees, it's just a little bit easier because we're a little more comfortable with degrees. This is 180 and this is 270. So we know 240 will be in quadrant 3. So this angle in the negative direction, if 360 is all the way around and I've used up 240, I'm left with 120, but that's in the negative direction. Remember that degree symbol. And then to get the one that goes all the way around, 360 plus 240, 360 plus 240 will give me 600. Okay, the next part, 7 pi over 4 we should be able to do without a calculator or without any work, really. 7 pi over 4, oh, they want a complement and supplement. Okay, I was thinking we had to put this in degrees. But 7 pi over 4, if we want to find a complement, the first thing I'm going to do is sketch it. And 7 pi over 4 is going to be in the fourth quadrant. So it's already past 90 degrees, or pi over 2. So there is no complement, and it's also past 180 or pi, so there's no supplement. We don't use negative angles to add to figure out complements and supplements. They're going to be acute angles, so they are acute or obtuse, but they're always positive. Okay, 2 pi over 7 for the next one. I know that that is going to be in quadrant 1. So since this is a decimal, a really quick way to get 3.5 pi over 7 not to have a decimal is I'm going to multiply the top by 2, the bottom by 2. So that would be 7 pi over 14. 2 pi over 7 is 4 pi over 14. So to figure out the complement, I'm trying to figure out what would I add to 2 pi over 7 or 4 pi over 14 to get 7 pi over 14, and that is going to be 3 pi over 14. So the complement will be 3 pi over 14. So we don't want a decimal in a fraction. The supplement, if I want to add to get 7 pi over 7, I've used up 2 pi over 7, the complement's going to be 5 pi over 7. Okay, the next one, to express the angle in radian measure, we just memorized this is 390s or 3 pi over 2s. Number 10 is 5, or it's 345s, but in the negative direction. So 3 pi over 4 is in the negative direction. To get radians into degrees, I know that this is 2 pi over 3s or 260s, and it's in the negative direction, so negative 120 degrees, and then pi over 2 is half of pi, or half of 180, which is 90 degrees. Okay, then when you are converting using the calculator, I normally just let the degrees alone so that I'm not adding negative 42 to something and then getting negative 41, which would be the wrong degree. I'm just going to do negative 42 point, and then this is seconds. So I'm going to figure out on the calculator 15 over 3600. So it's going to be, and depends on what we're asked to round to, but it's negative 42.00416 repeating degrees. And then to convert to DMS, this is where we're going to use the calculator. So we're going to put this number, this decimal, into the calculator, and then go to second angle, and then I believe it's number 4 is DMS, and it will change it right away for you to 32 degrees, 51 minutes, and 14 seconds. Okay, the next one, and these are the ones that are probably the toughest. Determine the angle measure formed in radians if the circle has a radius of 3.8 inches and an arc length of 9 inches. We have this formula, S equal R theta. It basically is how we get what 1 radian is. If the arc length and the radius of a circle are equal, then that's considered 1 radian. So what I'm going to do for S is put in the arc length, which is 9 inches. I'm going to put in the radius, which is 3.8 inches. And then I'm going to solve for theta. And what you could do just to get rid of decimals, if we're dividing 9 by 0.38, I could multiply them both by 2, or by 10, or I could do 2, but that wouldn't get rid of my decimal. So if I multiply by 10 over 10, I'll get 90 over 38, or 45/19. That's in radians. We could write RAD, we don't have to. Number 16 asks for a circle that's a radius of 10, has a central angle that's 50 degrees. Most important thing here is to change that angle to radians before you use the formula. So you want to switch that to get that it is 5 pi over 18. And then I'm going to use S equals R, which is 10, times theta in radians, which is 5 pi over 18. And then I could either use my calculator or I could just leave it as a fraction. It's 25 pi over 9, and that's in meters because the radius was in meters. And theta is unitless. Okay, number 17, we want to determine the radius of a circle if the central angle is 145 degrees and the arc length is 8 meters. So the first thing I want to do is change that angle right away to radians. Once I get that angle in radians, then I can use S equal R theta. It told me the arc length is 8 meters, and I have 29 pi over 36 as my angle. So the easiest way to solve this is to multiply by the reciprocal. So I'm going to multiply both sides by 36 over 29 pi, and then I can get my answer, which is going to be 3.16 meters. You can just put that in the calculator, 36 times 8 divided by parentheses 29 times pi. Okay, the second part of this worksheet, which you were working on, is the circle, and I think I might have a better solution so you can see it. Let me find a solution to that. It was, I believe, page 8. Okay. So going around the circle, you can check to see if you have the correct answers. What I do when I am using this is I go through, and probably I would put all of the angles first that are in, maybe the quadrant angles first. That's probably the easiest thing to do. So I'll put those quadrant angles in. Okay, so this would be the 0, the 90, pi over 2, 180, and then 270. Okay, and then I'd probably do the 45s. And I'm just counting. So 1 pi over 45, 2 pi over 45 I already have, 3 pi over 45, 4 pi over 45 is pi, 5 pi over 45, 6 pi over 45 I already have, 7 pi over 45. Then I can go and put those in degrees. 45, 90, 135, 180, 225, 270, 315, and back to 360. And then I'd probably can count 3 30s in each 90, so 1 pi over 6, 2 pi over 6 I'll reduce to pi over 3, 3 pi over 6 I already have, 4 pi over 6 reduced, 5 pi over 6, 6 pi over 6 is pi, 7 pi over 6, 8 pi over 6, oops, right here, 9 pi over 6 I already had as 270 degrees, 10 pi over 6 reduced, 11 pi over 6, and then I'm back all the way around. And then I could put those in the family of 30s, 30 degrees, pi over 6, 150 degrees, 5 pi over 6, 7 pi over 6 is 210, 11 pi over 6 is 330. I think 11 30s, 7 30s. And then back to the pi over 3 family, pi over 3 is 60, 2 60s is 120, 4 60s is 240, and 5 60s is 300. Okay, email me with any questions. Hopefully that helped clear some of those questions up.